Download this code from codegive.com, link in the description below. OK, let's dive deep into protecting your APIs against SQL injection threats using Apigee. This is a critical security concern, and a layered approach involving Apigee can significantly reduce your attack surface. This tutorial will cover the concepts, techniques, and code examples to implement SQL injection protection in Apigee. Understanding SQL injection. SQL injection, sqli, is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. It typically occurs when user-supplied data is incorporated into a SQL query without proper sanitization or validation. An attacker can inject malicious SQL code into application input fields, potentially allowing them to bypass security measures, gain unauthorized access to data, read sensitive data, extract usernames, passwords, credit card details, personal information, and other confidential data, modify data, alter records, add malicious code, or deface websites, delete data, erase entire tables or databases, execute arbitrary commands on the database server, potentially taking control of the entire system. Why Apigee for SQL injection protection? Apigee, acting as an API gateway, sits between your clients and your backend database. This strategic position allows it to centralized security, apply security policies consistently across all your APIs. Input validation and sanitization, inspect incoming requests for potentially malicious SQL code. Rate limiting and throttling, mitigate brute force attacks and prevent attackers from overwhelming your system. Logging and monitoring, track suspicious activity and identify potential attacks. WAF functionality, Apigee provides web application firewall, WAF, capabilities, providing a comprehensive set of policies for filtering out common web attacks. Abstraction, protect your backend database by hiding its structure and implementation details from external users. Core concepts and techniques. 1. Input validation and sanitization, whitelisting, only allow known good characters or patterns in user input. For example, if expecting a numeric ID, ensure the input consists only of digits. Blacklisting, not recommended as a primary defense. Identify and block specific SQL keywords or characters, example select, update, delete, // However, blacklisting is easily bypassed by clever attackers who can use encoding, case variations, or other techniques. It should be used in addition to whitelisting and parameterization, not as a replacement. Encoding, encodes special characters that could be interpreted as SQL operators. For example, replace single quotes with backslash or HTML, encode them as end oppos. Regular expressions, regex use regular expressions to define acceptable input patterns. This can be effective for validating data formats like email addresses, phone numbers, or dates. 2. Parameterization, prepared statements. The most effective defense, instead of concatenating user input directly into SQL queries, use parameterized queries or prepared statements. This technique separates the SQL code from the data. The database driver handles the escaping and encoding of the parameters, preventing attackers from injecting malicious code. Important *, this is a backend implementation detail. Apigee cannot directly enforce that your backend uses parameterization. However, by sanitizing and validating inputs before they reach the backend, Apigee can help ensure that the data sent to the backend is safe for parameterization. 3. Web Application Firewall, WAF, Policies Asterisk. Apigee's WAF module. Apigee's WAF module offers pre-built rules and policies to detect and block common web attacks, including SQL injection attempts. You can customize these rules to fit your specific application's needs. 4. Rate limiting and throttling asterisk. Prevent brute force attacks. SQL injection attacks often involve trying multiple payloads to find a vulnerability. Rate limiting and throttling can limit the number of requests from a single IP address or user, making it harder for attackers to succeed. 5. Logging and monitoring asterisk. Detect suspicious activity. Log all API requests, including the request headers, query parameters, and body. Monitor these logs for suspicious patterns, such as the presence of SQL keywords or special characters. Set up alerts to notify you of potential attacks. Implementation steps with Apigee Edge. Here's how you can implement SQL injection protection in Apigee Edge using various policies. 1. Assign message policy, for setting variables. We'll use assign message policies to extract and manipulate request data. This is used in conjunction with other policies. Explanation asterisk. Assign message, the policy type. Name, a unique name for the policy. Assign to, specifies where to assign the variable. Transport equals request means we're working with the request. Type equals query param targets query parameters. Assign variable, assigns the value of the query parameter to a flow variable. Name, the name of the flow variable, example input.param.id. Use dot notation for organization. Value, the value to assign, obtained using message templates, request.queryparam.id. 2. Regular expression protection policy, for validation. This policy will use regular expressions to validate input against a defined pattern. We'll use this to check for potentially harmful SQL syntax. Remember that overly aggressive regex can lead to false positives, so strike a balance between security and usability. Explanation asterisk. Regular expression protection, the policy type. Name, a unique name for the policy. Properties continue on error equals false. If the policy fails, regex doesn't match, the flow will stop. Set to true if you want the flow to continue even if the validation fails, not generally recommended for security. Source, the variable containing the input to validate, example input.param.id we set earlier. Regex, the regular expression pattern. In this case, 0 to 9 plus $ matches strings consisting only of one or more digits. This is a very basic example. More complex regex patterns can be used to check for more sophisticated SQL injection attempts. Type, the data type of the input. Action, what to do if the regex doesn't match. Abort stops the flow immediately. Other options include continue, logs the error but allows the flow to proceed, or raise fault, raises a fault condition, which can be handled by a fault rule. Expression to evaluate, in this case just the input parameter. Example regex patterns prevent SQL keywords I, caret. Select update delete insert drop union exec concat substring char, $. This pattern is case insensitive and will block any input containing those keywords. Check for SQL comments caret. --/// dot $. This pattern blocks inputs containing SQL comments. Prevent special characters caret caret. asterisk dollar, blocks single quotes, double quotes, and semicolons. Important asterisk regex patterns can be very complex. Test your patterns thoroughly to avoid false positives asterisk. 3. XML Thread Protection Policy, for XML payloads. If your API accepts XML payloads, use the XML Thread Protection Policy to check for malicious XML structures, including those that could be used for SQL injection via XPath injection, a related vulnerability. Explanation asterisk. Asterisk source, request means the policy will inspect the entire request. Asterisk message buffer payload equals true, forces the policy to buffer the entire payload before processing it. This is often necessary. Asterisk max depth, max element count, max attribute count, limits on the complexity of the XML structure to prevent denial of service attacks. Asterisk disallow doc type equals true, prevents document type definitions, DTDs, which can be used for malicious purposes. Asterisk masked elements, elements to mask in logs to protect sensitive data. Asterisk use strict validation equals true, enables strict XML validation. Asterisk XPath, specifies XPath expressions to evaluate. You can use XPath to look for specific patterns or structures that could indicate an attack. The example expression count, / evil, counts the number of elements named evil. 4. JSON Thread Protection Policy, for JSON payloads. Similar to XML thread protection, use the JSON Thread Protection Policy to prevent attacks through JSON payloads. This includes preventing JSON injection, which can be used to bypass backend security. Explanation asterisk. Asterisk most settings are similar to XML thread protection. Asterisk max string length, maximum length of strings in the JSON payload. Asterisk object entry name length, maximum length of object entry names, keys. Asterisk use strict validation equals true, enables strict JSON validation. 5. Quota and spike arrest policies, for rate limiting. Use these policies to prevent brute force attacks by limiting the number of requests from a single user or IP address within a specific time window. Explanation asterisk. Asterisk quota asterisk limits the number of requests per time interval, example 100 requests per minute. The identifier is used to distinguish different users, API key, IP address, or other unique identifier. Asterisk spike arrest asterisk prevents sudden spikes in traffic that could overwhelm your backend. The rate specifies the maximum number of requests allowed per second or minute. 6. Raise fault policy, for error handling. If a validation policy fails, example the regex doesn't match or the JSON/XML payload is invalid, use a raise fault policy to return an error to the client. Explanation asterisk. Asterisk fault response, defines the HTTP response to be returned when the fault is raised. Asterisk payload, the error message in JSON format. Asterisk status code, the HTTP status code, 400 bad request is appropriate for invalid input. Asterisk reason phrase, a human readable description of the error. 7. Flow configuration, attaching policies. Now, attach these policies to the appropriate flows in your Apigee API proxy. You typically want to apply validation policies in the pre-flow of the request flow. This ensures that all requests are validated before they reach your backend. The quota and spike arrest policies can also be placed in the pre-flow. The raise fault policy should be triggered by a fault rule. Explanation asterisk. Asterisk the flows section defines the request and response processing pipelines. Asterisk the requests section specifies the policies to be executed on incoming requests. Asterisk step, each step executes a policy. Asterisk condition, specifies a condition for the flow to be executed. Example request.verb == get, means this flow only applies to get requests. Asterisk fault rules, defines rules to handle errors. The condition determines when the fault rule is triggered. In this example, the invalid input fault rule is triggered if the rep validated JSON thread protection or XML thread protection policy fails. Example scenario. Let's say you have an API endpoint that retrieves user data based on an ID. Get/users, ID = 123. An attacker might try to inject SQL code into the ID parameter. Get/users, ID = 123, drop table users, dash. With the Apigee policies in place. 1. Assign message asterisk the ID query parameter is extracted and stored in the input.param.id variable. 2. Regular expression protection asterisk the rep validated policy checks if the input.param.id consists only of digits using the regex $0 to 9 plus $. 3. Failure asterisk the regex will not match the malicious input, 123, drop table users, dash. 4. Raise fault asterisk the rf invalid input policy is triggered, returning a 400 bad request error to the attacker. The malicious request is blocked before it reaches the backend database. Important considerations and best practices. Asterisk defense in depth asterisk don't rely on a single layer of security. Combine multiple techniques, input validation, parameterization, WAF policies, rate limiting, logging, for a robust defense. Asterisk least privilege asterisk grant your API proxies and backend database only the necessary permissions. Don't give your API proxy administrative privileges on the database. Asterisk regular security audits asterisk periodically review your API security configurations and policies to ensure they are up to date and effective. Use penetration testing tools to identify vulnerabilities. Asterisk keep software updated asterisk keep your Apigee Edge platform and backend database software updated with the latest security patches. Asterisk secure configuration asterisk harden the security of your Apigee Edge environment itself, example strong passwords, multi-factor authentication, access controls. Asterisk educate developers asterisk train your developers on secure coding practices and the importance of preventing SQL injection vulnerabilities. Asterisk false positives asterisk be careful of overly aggressive regex patterns that block legitimate requests. Monitor your logs and adjust your policies as needed to minimize false positives. Asterisk contextual validation asterisk the type of validation you perform should depend on the context of the data. For example, an ID field should have a very strict validation policy, while a free text search field might require more lenient validation. Asterisk logging sensitive data asterisk avoid logging sensitive data directly in your logs. If you must log sensitive data, encrypt or mask it before logging. Apigee's masked elements configuration can help with this. Asterisk understand your database asterisk be aware of the specific SQL dialects and features of your database, example MySQL, PostgreSQL, SQL Server. This will help you tailor your validation policies to the specific risks. Advanced techniques. Asterisk custom policies asterisk for more complex validation scenarios, you can write custom policies using JavaScript or Java. This allows you to implement more sophisticated logic and integrate with external security services. Asterisk threat intelligence feeds asterisk integrate with threat intelligence feeds to identify and block requests from known malicious IP addresses or botnets. Machine learning consider using machine learning-based anomaly detection to identify suspicious API traffic patterns that could indicate SQL injection attempts. Code example, custom policy, JavaScript. Here's an example of a custom JavaScript policy that performs additional validation. Attach this policy to the request flow, before your backend call. Then, you can add a conditional flow to the raise fault policy. Conclusion: protecting your APIs against SQL injection requires a comprehensive and layered approach. Apigee Edge provides a powerful set of tools and policies to help you validate input, sanitize data, rate limit requests, and monitor for suspicious activity. By implementing the techniques and best practices outlined in this tutorial, you can significantly reduce your risk of SQL injection attacks and protect your backend database from unauthorized access. Remember to regularly review and update your security configurations to stay ahead of evolving threats. Good luck.